Hey Space Engineers! If you're here, then it means you want to learn how to use MotherCore to build your own Space Engineers scripts. This series will walk you through many of the common use cases, and hopefully we have a bit of fun along the way. Let's get started. You'll notice the MotherDocs has gone through a pretty big overhaul. Most notably, you'll now have access to the MotherCore documentation. This documentation is quite different from MotherOS, mainly because it's architecture. It's going to explain to you how you can use MotherCore, and in fact, it will guide you through the development of a module that should more or less work after you've created it. If you want to go a bit deeper, of course, there is actually an architecture page where I break down a little bit more about the code base, and I guide you through some of the more nuanced areas of building a script for space engineers. Most notably, you're going to be building a module. Right? This is the meat and potatoes of what MotherCore enables. Everything inside of MotherOS, as an example, every capability, every command you're running, it's run via a module. So it's very smart to break up your program in this way, and I think you'll find that this is really easy to do with a set of tools that I've created for you. To get started, we're going to use MotherCLI. MotherCLI is it's a side tool that I've created. Think of it kind of like MDK2, where it does a bunch of installation and file management for you so that you can focus on doing the fun stuff and not worrying about where to put a file, how to create a file from a template, etc., etc. So the console exposes a bunch of commands to you, and we're going to walk through each of these in sequence in this demonstration, but this is the best place to come when you have questions about what this command line interface can do. And the reason I chose to do it this way is simply because MotherOS is also a command line interface, and the way that players will interact with your script is also a command line interface. So it made sense to hold this paradigm and be consistent across both the development and the user experience environments. What you'll want to do right away is install Mother command line interface. You can click on it here, and this is going to take you to NuGet. All you'll have to do is copy the command here, run it inside PowerShell, which I'll show you in a moment, and that'll give you all the tools you need to get started with your project right away. The other thing you'll need before you get going is the Malware Dev Kit version 2. Malware has done a great job throwing together a minifier, a package analyzer, and really just a lot of great tools to help making scripts for space engineers approachable. So don't sleep on this. You're going to need it. It's a dependency, pretty hard dependency. So get both the MDK and the Mother command line interface NuGet package installed. And then we're going to move on to creating a new project, which you can see right in front of you is a very straightforward experience now that you've got the tools installed. So let's actually put this into practice with a live example. So on my left-hand side, I have the folder that I want to be creating this project inside of. This is typically going to be where you write your code on your computer. If it's the first time, Microsoft will actually create a repos folder for you. We won't use that, just to keep the folder structure simple because I have quite a few scripts. So we'll create it in this folder here. And we're going to do the first action with our PowerShell. So you're going to want to open up Windows PowerShell. I haven't done this on Linux or Mac, but it would work inside their terminals as well. And firstly, what we're going to do is navigate to this folder. It's pretty straightforward. We just want to use the cd command, change directory. We're going to click in the bar here, and you're going to notice we get that address. So we're going to paste that here, and boom, we're going to notice that we're now inside of the source directory. I'm going to use the clear command to clear my console, and we're at a great starting point to start using Mother to actually do some work here. So we want to create a project, and I've come up with a fun idea for us today. We are actually going to make a script specializing in partying. So for this case, we're going to use Mother. We are going to run the new command to say create a new project, and we're just going to call this Mother Party. And I'm going to hit enter, and we'll see very quickly, aside from some annotation, we now have a Mother Party project folder created, and you can see we've done a bunch of things. We've created an example module for you, and I've installed MotherCore as well, which is a series of core modules that give you the capabilities that we're now going to see. So the next thing we're going to do is actually open up Mother Party, and we'll see our entire file structure has been filled out for us. This is all you need. You can compile this and run it in Space Engineers, and a few things will already be taken care of for you. So let's open this in Visual Studio so that we can get a sense of what the developer experience actually looks like. So we're going to click on Mother Party CS Project, which is going to open Microsoft Visual Studio for us. Okay, so now we're inside a Mother script project, and we'll notice that our PowerShell has actually already set us inside of this folder as well, which is great because all of the following commands we're going to run using mother command line is going to actually be run inside the mother party folder. This is our projects folder, and we can see right on the left-hand side we've got two main areas. We've got the modules folder, which we'll go through the example module in a moment, and we've got the core, which comes with every project, and this is the set of modules and commands that allows you to communicate with other grids, figure out where you are in space, and a bunch of other nifty tools that your modules can have access to basically for free. But we won't really open core, and in fact, you should never modify core. Core is something that I will be pushing updates for. All of your logic should in fact go inside the modules folder, which is where we're going to be doing all of our work today. So what I first want to do is quickly show you the example module, and then I'm going to actually talk through creating our own module, creating some commands and some events, and let's actually do some fun stuff with it. So inside of our example module, we don't really have much going on. We create a new module. It's derivative of the base extension module, and this is essentially, again, a collection of methods that make it really easy for you to do specific things. So I would suggest that all of your modules that you create extend the base extension module, and therefore you have to pass in the mother instance to the base instance. This is going to be, it's going to make writing your modules a lot more fun, quite honestly. There's a lot of scaffolding underneath here that just lets you get right to the stuff that's interesting. And you'll notice that we have a simple function here. And this is what our script is going to call. This is what the player will be interacting with momentarily, and I'll be able to show you that in just a second. But ultimately, we are passing in a string, or we use the Space Engineer string as the default, and we just print out a message to the user. If we want to boot, we have this boot method available, and of course, we need the player to interact with this module in some way, and that is where the commands come in. So the player will call a greeting command, and then we will effectively call this print greeting method to respond to that user's input. Like the documentation says, we run the program 6 times a second. So this is where you'd want to put logic that absolutely has to run 6 times per second. If it doesn't have to run that frequently, you probably don't need to use this function on this module, and in fact, you can delete this whole block of code. We won't do that in this case because, actually we will for the example module. It's not really relevant, so I'll prove the point. We can just delete that, save a few characters, and it has no impact on the ability to run. We also have the ability to handle events. We're going to cover events a bit later, but events ultimately allow us to listen for other modules doing things and then respond. So it allows our modules to not depend on each other. I just have to listen for specific events I can register based on the fact that they're part of my code base, and anytime that happens, I can do something irrespective of what that other module is currently doing. This is really powerful, and I think ultimately this is one of the keys to really make your aircraft work in a modular fashion. So what does that actually look like practically? So if we come in here, we do notice I've already installed our mother party. We'll do a recompile here. And mother party is a completely independent script. It doesn't run with mother OS or anything. It's a different script on my grid. Mother OS is actually running over here. But it works in very much the same way. And like I'd said, we had a greeting command. So if we come down and we run our arguments, we notice that we can type in a greeting. And if we press run, we'll notice we have hello, Space Engineer, just like we saw in our code. But of course, if I want to pass in, we'll just do Luke. If I want to pass in a name, we can also accept that as an argument and print that out to the user. Now, of course, that's the most simple implementation of using a command. But of course, you can see how this quickly scales out to the ability to do anything based on a player input with not too much overhead. You actually, in the process, saw how we took a bunch of information in and printed it without having to write any code ourselves. So I hope that demonstrates just kind of what Mother comes with out of the box that gives you access to some of these cool features. So now let's focus on creating something ourselves. Like I'd mentioned, we want to create our own module. So we're going to put our new module inside the modules folder, but again, we're going to let the mother command line tool do this for us. So we're just going to type in the mother make module command. What do we want to call this module? Well, quite simply, this is the party module. We'll let it be kind of the boss of the operation. And when I hit enter, you're going to notice we've created a new module inside the modules folder. And we have a default class here that we can open up. And this comes with scaffolding for all of the methods we saw earlier in our example module. Okay, so for now, there's not really much for us to do. But what we can do to get started is let's just start the party. Let's register a command that tells our party to initiate. So we're going to need a few things, but let's just start with the command itself. We're going to register that in our boot method, but again, mother CLI has a tool for us here. So we can go mother make command. What is the command going to be called? Well, it's going to be called start party command. And what we can do is actually assign this to the party module. This is great because most commands run logic, and you don't want that logic to be inside of the command. You want that logic to be inside the module that's responsible for that capability. The command is really just an interface between the player entering some text into the command line and your script taking action. It shouldn't actually be where most of the heavy lifting is. So when we make that, we're going to notice now that we have a commands folder. And now we just want to register the command by just passing in a new instance of that command and an instance of mother as its argument. And that's all we need to push a command through the system based on a user input. So if we open our start party command, we see a few things. Firstly, we have access to our parent module, which is in this case our party module. That's going to be useful later. And then we're going to find our command name. Well, let's imagine that we just want to call this party start. And that's what the player would end up typing to initiate this command. And then finally, we have a terminal command that gets spit out here. Now, we don't have any commands in the context of our module here, really. We just run a command with no arguments. So we're going to keep it simple for now. And what we're going to say is that the party has started. Right? That's the output. We expect the string to be printed to the player. Now, of course, we want to do something before we print to the player. There's the action of course, starting the party. Well, okay, this is where our module comes in play. So we have access to our module, and our module, we expect to have a method on it called start party. Okay, now we know we don't. We have an underline here that's telling us that method does not exist, but let's create that method. Okay, so we'll go back to our party module, and I'll actually pin these guys. So right under boot for now, we're not going to return anything yet, but let's just go start party. And in fact, if we really want, why don't we print the output here as well to prove the point using the mother print command. And this just takes in a string. And what we can do is actually go starting party. And we'll have once the command is executed, we'll see the other message printed saying the party has started. And so that's it. Now we can run the party start command. We are going to print this, and then we are going to return to the command line this. Now, of course, we have to make it public so that another module can call it. And that should be it. So we will build this, and let's go take a look in game whether it worked. One thing I forgot to mention, but it's pretty important, is that inside of our program class, we actually register our modules here. So you'll notice that right now we have our example module registered, and this is where we'd want to put in our party module. So once we plug in our new party module, we'll also pass an instance of mother. This is what's going to make it available to the rest of our script. So we'll just let our build tool run again, and then I will meet you in the game. We'll let it quickly boot up. And now we want to be running our party start command. And when we run that, we see the party is starting and the party has started. So there we go. So we have a new player interaction that runs some logic. Now, let's take this a little bit further because I want to show you how to use events. And events are going to be what enable us to do something pretty funky next. So I'll see you back in Visual Studio in just a sec. Okay, so here we are again. Let's open up our PowerShell and get back to where we were. Now, we talked about events briefly before, and ultimately I think this is a great opportunity to demonstrate when we want to start the party, we should probably be broadcasting an event that says party started. This lets any other module that might want to be participating in that party to get the signal and do their thing. This means that the party module actually doesn't have to do very much aside from announce when the party starts and stops. You can imagine that this is broadly applicable across use cases where, for example, when Mother OS flies you to a position or on a flight plan, every time you hit a waypoint, it's firing a waypoint reached event that will trigger the flight plan to advance or cancel or dock depending on the use case. So let's go through that now. So Mother CLI to the rescue again, and much like before we made a command, we are now going to make an event. So we're going to go mother make event, and this event is going to be called party started event. And just like our command, we are going to assign this to the party module. Ultimately, it's the party module that's responsible for managing this event. Everybody else should simply just be looking for it. So this helps us logically encapsulate it inside of our party module. So we'll do that, and then we'll notice inside of our party module folder, we now have an events folder. And inside of here, we can see that the party started event has been registered for us. And actually, you don't even need to modify this file. This is effectively just a codified placeholder that we can use around our application. And I'll show you how to do that here in a second. All right, so let's remember that we have our start party method here. Firstly, we're going to print starting party. But after that, we're going to actually have to do the stuff to start the party. And before we actually do anything more, let's just fire our event. And we have a really easy helper for this. All we have to do is call the emit method, where we pass in the type of the event being emitted. In this case, it's the party started event. And that's it. That means anytime we start the party, this event will be fired. And so any other module around our system can listen for it. Now, before we create a second module and get too complicated, let's actually look at how our party module can actually listen for its own events versus work through its processes procedurally. You'll remember from our other module that we had the ability to actually subscribe to events in our boot method. And we have a really easy method, again, through our base extension module called subscribe. And just like our emit event, we just pass in the type of that event, and we run that method, and that is going to subscribe the party module to the party started event. That means that anytime the party started event is fired, the party module will expect to hear something and take action against it. Now, we're not quite done. This does all the wiring, but this doesn't actually mean the party module does anything. This just means that it's listening in order to do something. And that's where this final handle event method comes in. Inside of this method, we really have the ability to triage which event is coming in and then ultimately take action against it. And so at this point, we only want to manage one event. So it's going to be a really simple logical succession of actions. Okay, so all we need to do is really say that if the event is the party started event, well, let's print out party started. Let's get this party started. Fair enough. And actually what I can do is throw in false, and this won't trim it in the console, so we'll be able to see all of it. Otherwise it trims it probably around here. And so all this other stuff just gets hidden to the player, which isn't very fun. Okay, so let's build this and I will see you in the game, and let's put this to the test. Okay, so there is the version starting up. Now remember, we should see a bunch of printouts now. What we're looking for is let's get this party started. Now when we run it, we can see it right there. Party started, let's get this party started. That means that we were able to listen for an event and therefore take action against it. So we didn't actually run that procedurally. The module listened for a broadcast from itself and then did something. And that is building a module with commands and events in a nutshell. Now what I'd like to do is quickly show you guys how to build a second module that listens for this event, just to prove that point that you can share events across multiple modules. And then I'm going to leave you guys there, and in our next video, I'm going to show you how to use all of these basic systems to build a little dance floor. What we need to do is create a second module that is responsible for dance floor stuff. So let's go mother make module, and we're going to call this the dance floor module. Well, notice on the left-hand side, we now have a dance floor module. Okay, let's not forget we have to register that. So let's go back into our program. Autocomplete to the rescue, nope. But so we can go dance floor module mother. There we go. So that is all we need to register it. And if we go into our module, we of course see that we aren't doing anything yet. But let's get up and running right away. Let's subscribe. So let's subscribe to our party started event. There we go. And of course, we also want to ensure that we do something with it. So if our event is a party started event, the dance floor is now open, let's dance. Why not? That prints something out to the player really easily to get us started. So let's build that and take a look in game. Okay, one last time. This is the most recent version of the script. If we run it, we can now see that the dance floor module also received the event and printed out the code. And there you guys can see it's been trimmed because we didn't use false. So that is a basic demonstration of how modules can share information with each other. And this decouples things and uses a queue system so that you don't have to worry about complexity issues trying to run too much code back to back. In a way, this kind of distributes that processing over multiple cycles if necessary, keeping things pretty efficient. So I will see you guys in the next video, and let's get to building that dance floor.